Okay. Okay, you guys start the second half first. Okay, we will talk. Okay. Okay. And so I'm going to start right now. Okay. In this point, I'm going to explain the two types of boiler. We have the fire tube boiler. You can see in this picture that the water is inside a tube and the fire is inside a chamber, right? This is the fire tube boiler. And we have the second, the most common, and this is the boiler that we're going to use or we're going to see in a building. That is the water tube boiler, right? And you can see that the fire is in a tube and the water is inside a chamber, right? Okay, let's gonna start with fire steam boiler. Okay, the fire steam boiler that is not the boiler of the picture. Let me check out something. Sorry. See, this is the fire. There's a mistake here. No. Fire tube. Sorry, there is a mistake here. This is the fire. You can see this one. This is the fire tube boiler. This is the water tube boiler. Okay. So sorry, I make some modification in the presentation and maybe I made that mistake. Okay, but. Okay, let's gonna start with fire tube boiler. Fire tube boiler is the common boiler that we're gonna see in a building. How work this boiler? Okay. Here we're gonna have the burner, right? And we're gonna have a pipe. This pipe will go inside the boiler. It's gonna be in charge of change heat, right, with the water that is inside. That is the reason that they call fire tube boiler, right? What we have to know about the fire tube boiler? What is important to know? Okay, the main type of fire tube boiler is this Scotch type, right? There's three things that we have to know. The direction in the tube of the fire tube boiler, the name is pass, right? The chamber in the combustion gas direction and call them passes, right? So when you're going to buy or you want to make a design of a boiler, you want to know how many passes is going to have the boiler. What is the reason that you want to know? In this case, you can see 4 passes, right? 4 times the pipe change of direction. Okay? Why? Why is it so important to know how many passes the boiler have, right? It's important to know because if you want to have a huge, high rate of transfer, you're going to need more passes, right? Depend on the design, depend on the temperature, because you have this steam here, right? So if you want to have a temperature, let's say of 150 degrees, okay, we're gonna need at least like 4 passes, right? But if you wanna have a temperature of 300 degrees, yeah, we're gonna need at least like a 10 passes, right? So Depending on the rate of transfer that we want to increase the number of passes, right? There is another important thing. What happened? You remember when I talk about the area of heat transfer? You remember when I talk about that the transfer between this point is going to be higher than the transfer between these two pipes, or let's say this is not a pipe, this is a chamber right here, right? And a starter pipe, right? What happened between these two pipes? The rate of heat transfer is going to be bigger than in these two pipes, right? Yeah, you remember that? Okay. The same thing happened. You have a bigger area of heat transfer in this point, but if you want to keep the rate of transfer, you have to decrease the area every time. Why? With the main purpose of keep the velocity of or the rate of heat exchange. To maintain the combustion velocity, boilers tubes are generally smaller and in diameter, and reduce the number in each of each pass. Why we have to do this? Okay. Let's say we have the same boiler. Okay. I'm going to explain you with 3 passes. Okay. Let's say here we have a chamber, we have the burner, right? 1, 2, 1, 2, 3. And we go to another chamber, and from this we go again, but with 2. Okay, there is 1 pass, 2 pass, and 3 pass. You can see that each time we reduce the area of heat transfer with the main purpose of keep the same combustion velocity. You know what happens? The flow of the combustion go faster here than here. You're gonna start to accumulate. You're gonna start to create corrosion in this part of the piping. You have to keep the same velocity in each pass. Okay? It's important to maintain the proper velocity and temperature in the combustion gas to prevent corrosion. Any question? Any question? Sure. Okay. Okay. When you have a Scotch type of fire tube steam boiler, you're gonna see a wet back and a dry back. I think in this picture it's too hard. It's a little hard to see, but here's a little more easy. When you have the dry back, you have the chamber for the other pass upside the boiler, upside the water, right? This return.
It's inside the boiler.
When it's a dry back, it's upside, and when it's a wet back, it's inside the water. What do you think about this? What do you think about if I tell you which of these type of Scotch boiler fire tube steam have a high rate of heat transfer?
The
Dry back or the wet back?
The wet back.
Yeah, why?
It's inside the water. So
And the area of heat transfer is going to be bigger.
it's bigger here.
Yeah. Now we have the water steam boiler. Okay. it's the same. It's not the same principle, but you don't have fire here. In this point, the fire, you have water here in this pipe, right? And you're gonna have fire inside the chamber, right? That's gonna be one of the difference of this boiler. Okay. For this kind of boiler, normally we're gonna use for medium and high pressure. Normally you're not gonna see this type of boiler in a building. If you wanna generate power or generation power, and an industrial process, you're gonna see this type of boiler. In a building, you're normally gonna see a part-2 boiler.
Why is that?
Why? Okay, the reason is like you remember that we have low pressure, medium pressure, and high pressure.
Yeah.
You remember I tell you that the flow in the low is bigger than the flow in the medium and the flow in the high, right? In a building, we need let's say we need an average temperature of, I don't know, 80 degrees in the pipe, in the water, or in the steam, let's say 150 degrees. That is gonna be enough. When we are talking about this kind of boiler, when we are talking about high pressure, we're talking about temperature of 600, 500. Normally for this kind of boiler, you're gonna expend more money in the pipe. Remember, the pressure in this type of boiler is gonna be higher. You're gonna need thickness pipe, right?
But which one is more efficient, water tube or fire tube?
Both are the same. I can tell you, yes. The question is, they are for different process.
Okay.
Okay, it's totally, it's depend because, okay, let's say I want to generate energy, right? And I'm gonna use fire to boiler. I need a boiler with, I don't know, 50 pass to get the same efficiency that the fire to boiler. I'm going to have a higher flow, right? But it's gonna cost a lot of money. So normally you're gonna use water to boiler when you need a high pressure and a high temperature. Doesn't matter the flow. In a building, normally you're gonna need a flow of 100 feet or a high flow in a very low temperature for the steam. Any another question? Sure. Okay. Let's going to explain the natural circulation in a water boiler. This was the first design of a water boiler. How this works? Okay. We have this tank. There we're gonna call it feeder. At this point we have this steam, right? We're gonna add heat in this point, right? Okay. What is gonna happen in this boiler? This boiler works with a different of density. Okay. Let's gonna see the temperature in this point. That is gonna be. Let's say that this is C1 and this is C2 and this is C3. The temperature in T1, that is this point, temperature in T1 is gonna be almost the same as the temperature in T2, right?
Yeah.
But what happened here? We had adding heat, right? Adding heat. So the temperature here is gonna be higher, right? So we know that in this point the density of the water is gonna be higher. It's gonna be the temperature in this point of the water is gonna be low in comparison with this point. So it's gonna be a natural recirculation of the water. This is the principle. The hot water go outside. The cold water go down. Right?
Yeah.
This is a principle of density. So, in natural recirculation in water boiler, we're gonna have this natural process. At this point, we're gonna have hot water, and we try to go up. It's gonna do pressure in this point. It's gonna create steam, but in this point, the water is gonna be cold, so we'll go down. Okay, and that is gonna be. It's like you remember the process of the natural cooling tower?
Yeah.
Yeah, it's very similar, but the difference is the water.
Is that heat applied?
Um,
Is that heat applied to the water?
yeah, in this point. Any question about natural circulation in a water boiler? Okay. We have to know this definition. The downcomer. You remember what is the downcomer? Okay. You remember this when we have the boiler and with this cycle of concentration, we need to discharge the liquid that is in the bottom, so you don't have so much skill. Yeah. So you remember? Oh, the same principle is here. The risers are the water that will go to the steam drums. We have the downcomers and we have the firebox. One question. What do you think that the center line of the steam boiler drum and the mud drum is the same? Okay. You have the steam drum, right? And you have, this is going to be small. Let's say the center line. What do you think is the same? You're gonna have here all the mud drum. No. All the things that you don't want to have. Okay. What? Sorry. What is the reason that the center line of these two drums are the same? The reason is for the lowest point of the drum is gonna be in the center line. So all this load, all the solid is gonna come here in the lowest part of the drum. Okay? It's important to know this if you want when you're going to make the design. And then you have the forced circulation in a water boiler. What is the difference? This is the difference. Now you're gonna use a pump. So you're gonna need less space to make a design of this kind of boiler. Any question about that? Okay, there is another type of water boilers, a steam boiler, which should be mentioned: the cast iron sectional, the cold tube steam boiler, the electrode type, and the thermal liquid. The cast iron, this kind of boiler comes in separate mode. When you buy this kind of boiler, you can buy the burner in separate with the chamber of steam or the furnace shed.
Yeah.
For the cold steam boiler, use a steam separator. That is gonna be the difference.
Okay. Is it?
You see?
No, I don't think so.
The steam separator.
Okay.
Yeah. Sorry. Okay. The cold tube steam boiler is going to use a separator. In this point, you're gonna have the combustion chamber. You're gonna create the steam, and you're gonna have a separator. The main function of the separator is to catch the bigger drops of water. I will explain what is a separator later. And the electrode type steam boiler. This uses the electrical resistance in order to cause heat to be generated when electrical current flow from one electrode to another electrode. There are two common types of electronic boiler: the submerged electrode boiler and the water jet boiler. Okay. And the last one that I think this kind of boiler they are very used in Europe. That is the thermal liquid steam boiler. Instead of water, a special thermal liquid is used. This liquid permits the use of high temperature at low operating pressure. Any question about the type of water? Okay, then we have the steam quality and purity. What is the steam quality? You remember when I said that the vapor is a mix between water, the vapor is a mix between air and water. In this case, when we have the vapor, we say that the vapor is a mix between vapor and liquid. Why liquid? Okay. When we create steam, normally sometimes the quality of the steam is not 100%. We have 50% vapor and we have 50% liquid inside the steam. That is the reason that sometimes we're gonna call light steam. Light steam is the real steam. Sometimes we have 40% of light steam inside a volume of steam. That means that we're gonna have 40% of water inside the steam. That is the reason that we're gonna call steam quality. We have this is the mass of vapor, right? And let's say that in this mass of vapor, only this quantity is light steam, right? That is gonna be a high quality steam, okay? And this is gonna be the total mass. So this is gonna be the total mass of vapor, and this is gonna be the total mass, the mass of live steam, right? So the quality of the vapor is gonna be the mass of vapor, that is this one, okay? In relationship with the total mass of the vapor. We're gonna call it the total mass. Okay? Any question? No? Okay. And we have steam purity. The steam purity refers to the amount of solid, liquid, or vapors contained in the steam. High purity steam contains very little contamination. Normally, steam purity is reported as the solid content. Okay? Okay, steam separator. A steam separator, sometimes referred to a moisture separator, is a device for separating a water droplets from steam. The type of separator equipment used depends upon the type of boiler and design, the operating pressure, the boiler water treatment program, and the quality of the steam required. Okay, this is one of the most important parts in the when you design a boiler. That is the water balance of the steam generating system. The water balance focuses on water efficiency. It is common practice to calculate the amount of water of steam to be treated. Okay. We're gonna have E is gonna be the amount of heat produced by the. This part is important. I'm gonna explain some equation for the balance of the steam generating system. So it's important that you know each of these letters. Okay. E is going to be the amount of steam produced. BG is going to be the blow down rate. If W is going to be the feed water. The CDR is going to be the condensate return rate. the MU is gonna be the makeup water. That is for the equation. That is all that you have to know. So, what is blow down?
Sorry?
What is blow down?
Bleed water, the bleed,
Okay.
the mud.
Okay. What is the makeup water?
The fresh water or the recovered water that we bring into the system.
Okay. We have a new term, condensate return. Condensate is all the water from the blow down that, let's say, that we can treat and we can put again in the system. We can save a lot of money with this process, with condensate.
But that pipe doesn't come from the heating units or heating elements also? Whatever steam that it got condensated goes back to the system through the aerator?
Yes.
I'm talking about the heating system.
The heating system.
Yeah. So at the terminals, at the steam terminals,
Okay.
the water is going to condensate when the heat transfer happens.
Yeah.
So whatever is condensated, it comes through that CDR pipe, yes?
Yeah.
Okay.
And only that water can be, because that water is, you can treat that water and can go over here. The blow down is like a dirty water, real dirty water. You need a treatment water at this point.
Has to be treated, that one.
Yeah.
Didn't you have a steam trap on that?
Yeah, I'm gonna explain. You're gonna put the steam trap in this point. Sorry. You're gonna put a steam trap in this point, but I'm gonna explain you what is a steam trap later. Okay? Okay, we have blow down. We have flash steam. Flash steam, you know, is that vapor, is that steam of low quality, of real low quality, but we can still save some of part of that steam, or we can use that steam to preheat the water that is going to enter to the system. You know, that's the reason that we call flash steam. Is the relation of energy conservation. Is a technique to save part of the steam that we're gonna use in the system. Let's say that we have a real bad quality of steam here. Okay, one of the techniques that we can use, we have, let's say that this is the feeder. Inside is water, right? Okay, we can use this steam of low quality. This is a pipe, and go inside, and we'll start to preheat, right? And maybe this can go together. This transfer hits this condensate this point, and can go inside the system or can go inside a water treatment and then can go to the system. And we can save a lot of money and, you know. Okay, if you learn this, the equation is gonna be so easy. What goes in equals what comes out. Okay. These are the equation. Steam rate. You have all this equation. You have all this equation in your book. And the steam rate. For the steam rate, depend if you have from gas natural consumption, from fuel oil consumption, from boiler horsepower rating. You have the blow down rate. You remember that I said the blow down depend on the cycle of concentration, the feeder rate, and the condensate return, and the makeup required. Okay, I'm gonna do an example here. Okay. In this problem, another thing. Okay. When we are talking about percent or efficiency, and we have a percent upload. Percent upload is the flow that the boiler was designed. That can be when you build a machine or you design a device, you
So that's
never
predetermined. The percentage of load is predetermined.
is what? Sorry?
It's predetermined.
Yeah.
Yeah,
In
the
the way.
manufacturer gives you the.
Yeah, you're never gonna work with 100%.
I understand. So what? Like that's a factor that the factory gives you. Says this is the amount of steam that goes through this boiler.
Yeah, they're gonna say this boiler work with an 80% of load. We designed this to use to the 80% of the capacity. Okay, you should not use more. And the efficiency is the amount of this load that you can turn in steam. Okay, so you can have let's say 40%. But important is that you know the difference between load and efficiency. The load, when you make a design, when you make the design of boiler, you say you're gonna use this boiler 75% of the capacity. Okay? Efficiency is the amount of water that you can turn of water. Okay? Any question? Okay. In this problem, okay, we have, you can see,
Yeah, I can check it.
200 hours, 100, this is the problem. Okay, the steam boiler is working with a 80% efficiency, right?
60% load.
And 60% of load, right? Okay, if we go to the equation, we can see that 1 bhp produce 34.5 pound of steam per hour, right? So I'm gonna have E is going to be equal to 200 HPV multiplied for, we know that 34.5 per hour, right? Okay, well, I can explain you simple, or I explain you like, this is the mathematical way.
Yeah.
Okay. And this by the efficiency
85.
and the load, 45, right? And
65. 60.
65.
60. 60.
Oh, 67.
60.
Yeah, 60. So, mine.
No, it's okay. Okay. Well, Oh, it's the same. You put 6 or 16?
Yeah.
Okay. That is 3,500 pounds per hour of steam, right?
Yeah.
So right now we have this. Now we want to know the blowdown. For the blowdown, we need to know the cycle of concentration. The cycle of concentration is gonna tell us how many times the water has to go into the system before we have to discharge this water. Okay? In this case, the cycle of concentration is pi. The equation says that the blowdown is going to be E times 3,519, right? It's going to be the cycle of concentration 5 minus 1. And it's going to be 179.8 pounds per hour. So right now we have these two, right? Well, we have this. It's important to know only this. Normally we're not gonna have a blow down here, okay? We put this here, but normally we're gonna have the blow down in the boiler. Okay? So let's check this out. Okay. And then we have E, we have the blow down. So how much is gonna be the feeder? How much is gonna be this? Okay. We have this one, we have the pounds per hour of steam, and we have the pounds per hour from the blowdown. What is gonna be here?
The total, I don't know.
The feeder is gonna be E plus the blowdown. You can see that you don't create anything. It's the same flow. What is going in and go out is gonna be here. Okay? Any question?
Yeah.
No. So here it's gonna be equal to 9.8 pounds per hour plus 3,519 pounds per hour. Okay? That's gonna be equal to 5,000.
4,398.8.
Okay. In this case, we don't have a condensate return. What happens if we have a condensate return? Okay, let's gonna do this equation. What is gonna be the makeup? Somebody can tell me what is the makeup?
Sorry?
What is the makeup?
What is the makeup? It's the water that you needed to put in the system.
Yeah. Then it's the water that you need to put again in this system. Because you lose water here and you lose water here, right? Okay. I'm gonna put two situations for the makeup. In this situation, in one situation, the condensate return is gonna be equal to 0, right? And in the other one, the condensate return is gonna be equal to, let's say, 1,000 pounds per hour. Okay? we have this one, right? So we can say that feeder is equal to the makeup plus the condenser return, right? These two go to this one, right?
Yeah.
So if we want to know how much is the makeup is going to be the feeder, right, less minus the condensate return, right? Like I say, we have two cases. Case 1, case 2. Okay? In case 1, the make and return is equal to the feed. Yeah?
Yeah.
And the second one, the make and return is equal to, we were
399 minus 1,000.
sorry. And the makeup is gonna be 3. It's gonna be less. You're gonna save a lot of money.
So
Okay.
we need the condensate return.
What?
We need the condensate return.
Yeah. They have to tell you how much is gonna be the condenser return.
But what would 0.20 point water make up? What's that the amount
Percent?
on the slide?
They're going to tell you the pounds per hour.
Oh.
Okay. Let's go to talk about the steam trap. Okay, sorry. This is so important that you understand this part. It's gonna be easier if you know that the balance, what's go in, go out. If you have doesn't matter the drive. If you have two lines, and you have if and you have P, I don't care. And this is L. And you have the flow in this direction, right? L is going to be E plus P, right? That's the conservation. Right? If you know that rule, it's gonna be easier for you. Okay. Okay, a steam trap. Why we use the steam trap? Like I said before, in this point, we use the steam trap. We have the steam in this point, but we want to be sure that the quality of the steam is good, right? So, in this point, we put the steam trap with the main purpose of increase the quality of the steam, and in the same time take the water of the steam and take one part of that liquid and take it here. Right? When you make the design, the engineer that makes the design have to tell you if the flow, the trap is gonna take the 20% of the rate of the steam, and you know how much is gonna be the flow. Okay? It's important to have a plan on maintenance in the steam trap. Surveys have shown that major industry plants with a regular steam trap maintenance program show an average of 10% of all the steam trap to be inefficient. What happens if the quality of the steam is low? You're gonna have a lot of water in the steam. So you're gonna increase the rate of corrosion in the pipe. Okay? there is three type of inspection in the tram: the visual, the thermal, and the acoustic. Okay, and this is the final slide. Okay, when you're gonna store out of service a boiler, there is two methods. There is the wet layup and the dry layup. The wet layup refers to the boiler being completely droplet with chemical treatment water, and the dry layup refers to removing all the water, completely drying all water side surface and maintaining a dry condition during storage. The wet layup generally is for short-term storage, when boilers need for online service quickly, require in areas of high relative humidity. The dry layup generally is for longer-term storage, require if freezing condition exists. Not recommended for areas with high relative humidity. Sorry. Well, this is all. This is my mail. If you have any questions, send me a mail. So, this.
Do you guys have any questions so far?
Do you have any questions?
So,
Thank you very much for this opportunity.
So I know you've got something to do, what you already told me. Basically, took on presentation 2, Senegal College give a souvenir for your effort. Thank you for sharing some experience. For sure, I believe, all these, you believe the experience you share is very valuable, right? Maybe give him one more sort of encouragement. Thank you so much. Your slide, you're going to give it to me, I'm going to post it.
Oh yeah, but I have this slide a little shorter. I have to complete the slide. Or you want to
No problem. Well, we talk. Maybe you send it to me.
Okay,
When you
tomorrow I
finish.
can
Or,
show you.
yeah. Okay. It's not you much. Next week I'm going to review some water balance, as I mentioned. Okay. The major, the main reason I invite Enrique is showing you the concept. Okay. Steam boilers, some designs, different functions. So hopefully you guys grab the concept. Starting next week, I'm performing the water treatment for steam boiler, and I will do the calculation for water balance. We're going to do the problem. It will be important.